Hi, we are going to do 8 in 4, Lesson 8, Linear Equations in Disguise. We are going to once again use our building blocks from past lessons to convert problems into linear equations and then solving them. I'll show you the two keys to there's two keys to today's lesson, two key building blocks that you're going to need to put back in your memory bank in order to solve your homework. I'm going to teach you those, or remind you of those really, and then we're going to give you some sample problems and then some homework help. So let's get going. First of all, let's get over to our screen share where we're going to, right off the bat, get you the two problem types. And here they are. So the first two problem types are today's lesson types for lesson 8 are going to be cross multiplication, problems that look like this. And the second key thing is we're going to work with similar triangles, and we're going to need to remember our properties of similar triangles. So we'll go over these one at a time. So the first key is when you see problems that look like this, there's two ratios, a proportion, right? This is called a proportion. This is two ratios set equal to each other. And one key way, or one way to do it, the way most people solve it, is you do this thing called cross multiplication. You take the numerator of the left side and multiply it by the denominator of the right side, and then set that equal to the denominator of the left side times the numerator of the right side. So if we do that, let's see what happens. We take 7 times x and we get 7 times x on the left side. And on the right side, we get x plus 2 times 5. Now remember, if we multiply this times this, you have to multiply the whole numerator times the whole denominator. So we're going to have to pretend or remember that these are really kind of parentized like this. So if I multiply 5 times x plus 2, it really needs to look like this. My parentheses around the 5, I don't really need it because it's only one term. So that it's all the same if I have the parentheses there or not. But it's very important that you have parentheses when you have two terms or two things added together. And we're going to see this more and more today. So now what we have is we have a problem. And we learned this yesterday. What do we do when we see this? We distribute. So let's draw our distribution arrows. And we get on the right side 5x plus 10. And on the left, we simply have 7x. Okay, but it's all coming back from yesterday? Hopefully so. Let's now continue to solve our problem. Subtract 5x from both sides. And then we get 2x equals, these cancel, equals 10. Divide by 2. This should be getting more familiar to you now. We get x equals 5. Well, we think we have the right answer, so let's go through our check step here of taking this, plugging our x in, which is 5 for x. 5 over 5 plus 2. Does that equal 5 over 7? It's looking good. Well, that's 5 over 7 equals 5 over 7. Check. So we have the right answer. So we're going to do some more of these cross multiplications with a few twists and make sure that you get all the little nuances about it. And so that's the first problem type. The second problem type requires us to go back and remember what's true about similar triangles. And what's true about similar triangles is we take the ratio of a side in the triangle, in triangle 1, over, sorry, the ratio, basically ratio of the side 1 in triangle 1 to side 1 in triangle 2, side 1 prime, sort of, and set that equal to side 2 of triangle 1 to the side 2 of triangle 2. So what does this mean? This might not be written in the best way possible, but let's look at this. What we're going to do is we know that these are similar triangles because we say this. We say if triangle ABC is similar to, right? This is similar. This symbol that looks like this, the squiggly, means similar to. So that means that these are the same shape, different sizes. So we know that these angles are the same. We know that these angles are the same. And we know that angles C and C prime are the same. So what can happen, what we can say is we know, remember, that the side AB, the ratio of AB, the length of AB, divided by the length of A prime, B prime, right? The same side. If we take the ratio of this divided by this, that equals the ratio of BC over B prime, C prime, right? This side divided by this side. In other words, the amount that this side is blown up, whatever we multiplied this guy, 8x by, to get to 9 is the same as what we multiplied x minus 1 by to get to 15. So let's write this out. Well, side AB is x. The length of side AB is x, because that's what it says. Over the length of this one is 9. And the length of this guy, BC, right? 2x minus 1 over 15. These ratios are consistent. The amount I blow this side up to get to this side is the same as the amount I blow this side up to get to this side. So now, what do we have? Now we have a cross multiplication. We have the same kind of problem that we had in problem type 1, but we just did it from a picture. We started with a picture instead of an algebraic expression. Now, how are we going to solve it? We're going to solve it the same way. We're going to cross multiply. And we get 15x. And here we get 9 times 2x minus 1. Distribute. 18x minus 9 equals 15x. Subtract 15x from both sides. Let's take it up here. Well, we get here, I'll write this down here, equals 3x minus 9. So now we have 0 equals 3x minus 9. Add 9 to both sides. And we get 9 equals 3x. Divide both sides by 3, and we get x equals 3. So, have we solved it? No, we haven't fully solved it. What we want to do is we want to know that this side, what this side equals, well, x is 3, and 2x minus 1 is 5. So those are our sides, right? 2 times 3 minus 1 is 5. So 3 is to 9. 3 is to 9 as equals 5 is to 15. And that's true because if we do our cross multiply, we get 45 equals 45. This is really just our check. But our answer is, this side is 3 and this side is 5. Okay, let's move on and let's let you try some of these problems, or let's work through some more problems here. These are just cross multiply problems. So I'm going to let you, if you want to watch, you can. Otherwise, I encourage you to pause and try with your scratch paper that you have that you're watching me do this video with, because you want to be using your math skills while you're watching. If you just sit and watch math, you're going to think you know how to do everything, but when it comes down to test time or when it comes down to homework time, you're not going to know how to do it. It's weird. So make sure you're trying these. Okay, so now I assume you've paused and tried both of these. So let's try our cross multiply. Well, I'm going to start doing this a little faster now. Negative 2x, that's these guys. And that equals 1 times x plus 9. Well, 1 times x plus 9 is just x plus 9. Negative 2x. Subtract x from both sides. Let's do this. We'll try putting our negatives on the left. Whoa. Divide by negative 3. We get x equals negative 3. That went kind of fast, but you can slow it down and rewatch it if you want. So let's do our check step. Well, if the teacher, I want you to check it, I'm going to have to do it myself. So negative 3, right? X is negative 3. So we have a negative 3 on our check step. equals -3 plus 9. Does that equal 1/2? Well, let's see. That's -3 is +3. -3 plus 9 is 6. Is 3, 6 equal to 1/2? Yeah. If we simplify this, it's equal to 1/2. Or we can simplify 3, 6, divide both by 3, divide by 3, divide by 3, and we get 1/2. That's one way to check it. The other thing we can just cross multiply. 2 times 3 equals 1 times 6. Yeah, 6 equals 6. Two ways to check that. So x is -3. Done. Now here, this one may have thrown you for a little loop. You're like, well, how can I do a cross multiply here? I don't have a denominator on the right side. Well, remember, we can always stick a number or a term that doesn't have a fraction. We can always put it over 1. And now we can do our cross multiply. On the left, we get 9x. On the right, we get x plus 4. 1 times x plus 4 is x plus 4. Subtract x from both sides. 8x equals 4. Divide by 8, divide by 8. X equals 4/8, which can be simplified. Divide top and bottom by 4, and you get 1/2. So x equals 1/2. Check step. 1/2 plus 4/3 equals 3 times 1/2. So we have 1/2 plus 4 is the same as 1/2 plus 8/2. Let me write that in meter. 1/2 plus 8/2 over 3 equals 3 times 1/2. It's the same thing as 3/1 times 1/2, which is 3/2. On the left, we have 9/2 over 3. Does that equal? This is looking a little weird. Well, on the left side, we can do this a couple ways, but I'll solve it one way. So this is 3/1. So that's the same thing as 9/2. When we divide by a fraction, we have to multiply by the inverse. 9/2 times 1/3. Does that equal 3/2? Well, let's see. Cancel, 1, 3. And we get 3/2 equals 3/2. So we have checked it. So x is 1/2. This is correct. Once you're here, there's a lot of ways to go from here to checking your answer. I went one way, but if you did it another way and you come up with 2 equal numbers on either side, then you did it correctly. And there's no reason you have to do the math exactly how I did it here. I just chose one way that I find easy for me. Okay, one more to check. Now I'm telling you that these are similar triangles. And look, I kind of twisted this one a little bit, but I think you can figure out what's going on here and see what is similar, which pieces are similar. It's x, y, and y, z. I like to write it out when I write my similar triangles. So watch what I do. To just make sure I don't screw up. I say xy over x prime, y prime equals yz over y prime, z prime. This way I really can't screw up my ratio by getting confused about which links match up to which sides match up to which sides. So xy, there we go, that's 2. That's xy is 2. Oh, over x prime, y prime, well, that's 8. That equals yz, that's a minus 2, over y prime, z prime, that's 2a. Okay, now I have my cross multiplication problem. I have 4a, that's 2 times 2a, equals 8 times a minus 2. Distribute. Subtract 8a from both sides. Negative 4a equals negative 16. Divide by negative 4, divide by negative 4. And I get a equals 4. So if A is 4, then this is 2, this is 2, this is 8, and this is 2 times 4, this is 8. So let's go back and check. 2 over 8 equals 2 over 8. Check. Good. So A is 4. That's our answer. Let's put down some Happy Cat. We got to get some Happy Cat going. Haven't had Happy Cat today, and you've done a lot of good work so far. So we've got to bring that Happy Cat in. Okay, let's go on. And now we're going to go to homework help, which is time for you to try some problems. So definitely, whether you paused and tried last time, I want you all to pause and try. Then I will solve. Okay, I assume you're all back now. So now we're going to do our cross multiplication. 6 times x plus 2. Remember, you can't write 6 times x plus 2. This is not correct. You need to make sure that that's in parentheses because it's a 6 times the whole x plus 2. So remember, when it's the whole, put those parentheses on. Equals, similarly, 2 times 3x minus 1. The whole times the whole equals the whole times the whole. We have 6x plus 12 equals 6x minus 2. And so we subtract 6x from both sides, and we get 12 equals negative. What? 12 equals negative 2? What is going on? That's not true. Well, remember from yesterday that when you end with false statement, there are no solutions. So the answer is no solution. For those of you who got that one right, Happy Cat for you. For those of you who don't remember, you're going to remember it now. Let's go on. I won't throw another trick like that at you. Not in these last few problems. So now we're going to go again. 2 times x plus 2 equals negative 1 times 2x minus 4. Distribute. 2x plus 4 equals negative 1 times 2x is negative 2x minus negative 1 times 4 is negative 4. So that's equal to negative 2x plus 4. Okay, so those of you, some of you learned it like this, where you take this negative 1 times your 4 and then put that there and move the sign down. The other way to do it is just to take this negative 1 times the negative 4, which is a positive 4, and put that here. And notice it's the same answer. So depending upon whether you like to do the negative 1 times the 4 and move the negative down, or you take the negative 1 times the negative 4 and move the whole thing down, either way is fine. You'll get the same answer. So now let's subtract 4 from both sides and add 2x to both sides. And I get 4x equals 0. Divide by 4, and I get x equals 0. Let's check our answer. That seems suspicious. Let's see, 0 plus 2 over 2 times 0 minus 4. Does that equal negative a half? Does 2 over 2 times 0 minus 4, negative 4. Does that equal negative a half? Well, 2 divided by negative 4 is negative 2 over 4 equals negative 1/2. Yes, because I can simplify the left side to negative a half, and that all checks out. Happy cat. Spinning happy cat. Meow. Oh, Ray K. Okay. What did we forget to do here? Yes, we haven't done one of these problems. We have a similar object problem. Don't let the fact that these are quadrilaterals throw you off. And don't let the fact that this is not a fraction throw you off. We showed you how to do these ones. Okay, pause and try. Okay, we take this one and we rewrite it. We rewrite the right side as a fraction, and then everything falls into place. 1 times x plus 5 equals 9. So 1 times x plus 5 is x plus 5 equals 9. Subtract 5, x equals 4. Check our answer. 4 plus 5 over 3 equals 3. 4 plus 5 is 9 over 3 equals 3. Yes, 9 over 3 does equal 3. Happy cat. Okay, last but not least. Well, if these are similar, then I can take BC over B prime C prime, and that should equal the length of AD over A prime D prime. The ratio of these two sides has to be the same as the ratio of these two sides. So 2 over 3 has to equal x over 2x plus 4. Cross multiply. 3x equals 2 times 2x plus 4. 3x equals 4x plus 8 minus 2 over 3 equals x over 2x plus 4. Okay, so let's subtract 4x from both sides, subtract 4x from both sides, and we get negative x equals 8, or x equals negative 8. Now let's look at this for a second. So I get this side is negative 8, because x is negative 8, and this side is negative 8, which is 2 times negative 8 is negative 16, plus 4 is negative 12. So mathematically, this makes sense, but what is going on? Can I have a side of a quadrilateral that's a negative number? No, sides cannot be negative. Sides cannot be, so this is not a solution. So there is no solution. So I'm going to give you a happy cat. If you got negative 8, I'm going to give you a happy cat. But if you put it all together and you said sides cannot be negative, so there's no solution, I'm going to give you a double happy cat, because that's the real answer. So sometimes you can do your math and get an answer, but if that answer is not sensible, then you have to throw it out. Okay. Well, that was lesson 8. Linear equations in disguise. So we will be back with lesson 9 tomorrow. Hopefully this was useful to you. If it was, like it, tell your friends about it, send me a comment, leave a comment on YouTube, and we'll be seeing you next time on Mr. Lipscomb Teaches Math.